Okay, so today's topic is systems of linear inequalities. Our central question, how can you graph a system of linear inequalities? First of all, we need to understand what a system of linear inequalities is. And like last time when we were just studying systems of equations, they are two or more linear inequalities in two variables. And we have an example shown below with inequality 1 and inequality 2. Now, a solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality in the system. Just like last time, we're going to check and see whether or not ordered pairs are solutions to our systems. Okay? And what makes this different from what we studied last section? Well, not much. You'll just be graphing more than one line, remember solid or dotted, and then we'll still be shading, and our solution to that system will be the intersection of the shaded regions. Do you have any questions? I would encourage you to use colored pencils or highlighters or something that will allow you to distinguish the areas that are shaded from the shared shaded region, because remember, that is your solution to the system, the shared shaded region. So in order for us to verify whether or not a point is a solution to a system, it must be a solution to both or three or however many there are inequalities within our system. So we have two inequalities within our system, and we have to determine whether or not 3, 5, the point 3, 5, and the point negative 2, 0 are in fact solutions. So they must work for both. It's simply a matter of plugging in values. So that's exactly what I'm going to be doing here. Let's start with A. So I'm going to rewrite this system, and I'm going to plug in the 0.35 and verify whether or not that point is in fact a solution to the system. So y is less than 2x, and y is greater than or equal to x plus 1. I'm checking the 0.35, and I'm simply plugging those values into both inequalities within the system and verifying. So is 5 less than 2 times 3? It is, right? 5 is less than 6, so that is a solution to that inequality. I have to check the other one as well, verify both. I plug in 5 into the second one. Is that greater than or equal to 3 plus 1? And it is. 5 is greater than or equal to 4, so that works. Therefore, this is a solution. I'm going to repeat the same process with the other point, negative 2, 0. I'm going to plug it into the first one here, and again, I tell myself, is 0 less than 2 times negative 2? And in this case, it's not. So it's not a solution to, I don't know why I put parentheses there, but it's not a solution to the first inequality within our system, therefore it's not a solution to our system. I don't even have to check the other inequality. Okay, so that's not true. So not a solution. All right. Do you have any questions about this concept before we move on? No? Okay. Now, all the slide discusses is how to find a solution to your system via graphing. As we discussed before with inequalities, there is more than one solution. Unless those lines are parallel, then we have no solution, because there is no intersection. And the shaded regions indicate all the points that satisfy our inequality. When we're dealing with a system, we are simply going to identify the intersection of the 2 or 3 or 4 shaded regions. Okay? So in this case, they did their shading and they found that, in this example, there is an intersection of the shaded region there, so that means that area is in fact the solution to your system of linear equations. what do I expect of you? I expect that when you are shading, you make it very clear to me which is your solution. So which area is your solution? Oftentimes that means shading in very darkly that area that is a solution, or using color coding to help identify that. I should very clearly see when you're shading what your solution is, which area is your solution, and which area is not. So this discusses how to do that. You want to graph each inequality in the same coordinate plane, then find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. So step 2 is just a fancier way of saying the intersection of the shading is your solution to the system. Alright, so now we're going to look at graphing the system of linear inequalities. Here we have a 4x4 xy plane. As usual, make sure that you make clear to me how you are scaling your graph. This is clearly scaled by ones. You also remember the arrowheads on your plane, because a plane does go on forever in both directions, and that you label your x-axis with an x and your y-axis with a y. That is an expectation. You will lose points from now on if you don't have those things. Alright, so the thing I like to do when I start these, and you don't have to necessarily start it in the way that I do, is I like to graph the lines of the system without the inequalities, or at least write the equations, and then decide if they're solid or dotted, graph them, and shade. So, what I'm really looking at here, something similar, if it were an equation rather than an inequality, is y equals 3 and y equals x plus 2. The first one is what kind of line? Horizontal. It's a horizontal line. So I'm going to decide, is that a solid horizontal line or is it a dotted horizontal line? Yes. It's solid. So I'm going to graph that like I would any other line. It's a solid line. And then shade based on the direction of my inequality. So we have our inequality. It's pointing away from the y. So will that be shaded up or down? Down, below the graph, right? So, with another color here, I'm just going to shade below my graph. Again, you can use the test point system if you want to, but you don't have to. So that's the solution to one of my linear inequalities. Now I'm going to look at the solution to my next one. Is that a solid or a dotted line for the next equation? Dotted, right. Graph that line. I know that I'm going to start with my y-intercept of positive 2 and go up 1, over to the right 1, and down 1, over to the left 1. This is going to be a dotted line, so I'm going to get my dots. I'm going to shade this. Now it can get confusing when you're dealing with more than one line and several different shaded areas. So again, you want to make very clear what that intersection is. So based on the inequality, is it going to be shaded above that line or below? Above. Above. Remember, if it's facing the y is greater than, I'm going to be shading above. So the intersection of my two colors, the purple and the green, this region here is my solution. So what I want to do is I want to indicate that either by shading very darkly or by using a different color, or in any number of ways. So I'm just going to shade this in. That brown area there is my solution. So if you're just working with a pencil, just make sure that this area is shaded in very darkly, because everything else is just a solution to that particular inequality, but not to the system itself. Do you have any questions about that? It's exactly what you've been doing, you're just shading more than one in your graph, finding the intersection. Alright, so we're going to look at another system here. We can see that our inequalities are given to us in standard form. Ax plus by, in this case, is less than c, and ax plus by is greater than c. Normally, if I were to write this as an equation, it would look something like this. Normally, to solve something that's given to us in standard form, the easiest method is by a t-chart using the cover-up method. So I cover up my y, meaning that I replace the y with a 0 and I solve for x. And that allows me to find my intercepts. And then I cover up my x to find my y-intercept and solve for y. Now, I would actually not do that. I would discourage you from doing that with inequalities because it will help you with the shading if you isolate your y. So let's go ahead and just solve for y, isolate it, and then graph our inequalities. So for this first one, I'm just going to subtract 2x from both sides, and I end up with y is less than negative 2x minus 1. Same thing with the other inequality. Subtract 2x, and I end up with y is greater than negative 2x plus 3. What do I notice right away about those two inequalities? Yes. They're the same slope, which means what about those lines? They're parallel. So will they ever have a shaded region that intersects? No, not in this case. And we can see that, okay? We can see that when we graph them. We start at negative 1, and then we go up or down 2 to the right one. Go up 1, 2 to the left one. And we have a dotted line. This says y is less than, so I'm going to shade below. And we're going to drop the other one, positive 3 this time. And down 1, 2 over to the right one. Remember, it only takes 2 points to find the line. This is also dotted. Now with shading, I suppose there is a case in which you can have a solution. If this was shaded downwards, then this general area here would be the solution to both. But in this case, because of the direction of our inequalities, they're going in opposite directions, so they will not have a shaded region that intersects, therefore they will not have a solution. So it really just depends on the direction of your inequality. Is there an intersection of those shaded regions or not? If there is, then yes, there is actually a solution. But if there's not, then of course, you will not have a solution. So here, your answer would simply be no solution. Do you have any questions about that? All right. For those of you who are absent and watching this video, we practiced number 3 and 4, monitoring progress, and here are the respective answers for 3 and 4. 3 is no solution. 4, the darkest shaded region, is the solution to those systems of linear inequalities. I would put this in your notes so that you have it to study and make sure that you understand the concepts. Oh, This is my math joke for today. The importance of symbols in mathematics. This person just, I think just an elementary school kid, just saw the or and wrote or on everything. So again, mathematical language and the way we communicate mathematics can be vastly different from what we're used to in language arts. Okay, you will be asked to work backwards. Given a system, a graph system, you need to come up with, or I should rephrase that. Given a graph of a system, you need to come up with the system of linear inequalities. So take a few moments to pause this video if you're gone and copy that into your notes. Okay, so what I like to do to tackle this question is, again, come up with the equations first and then write those as inequalities. It just helps me. Some of you may not need to write the equations, you can go straight to the inequalities, and that's fine. I'm going to look at the dotted line first. I notice that I have a y-intercept of 0, so I have a b value of 0 for the dotted line. I also notice that I go up 1 to the right 1, or down 1 to the left 1, so I have a slope of 1. So in other words, this typically would be written, if it was an equation, as y equals x. So what I'm going to do to find my answer then is I'm going to write this as an inequality. Now, I look at the shaded region and I ask myself, is that shaded region above the line y equals x or below the line? Is it below or above? Below, right? It's below that line. So I'm going to have something facing away from my y. Now, is that solid or dotted? Dotted. So it's going to be less than x. Okay, and I'm going to do the same process for my other line. This is a horizontal line, and I have a y-intercept of 0, -3. So this is the line y equals 3. I'm going to write it as an inequality. The shading, is it going above that horizontal line or below? Above, so it's going to be facing. And then it's also solid, so it's greater than or equal to -3. -2. Perfect, thank you. Do you have any questions on how to find the system given a graph? We're going to try one more, and then I'll have to try some on the road. So like last time, if you're watching this video because you're absent or just watching it again because you want to have extra practice, take some time to think about this, write this in your notes if it isn't in your notes, and then we will discuss it. Okay, so again, I'm going to look at the lines as though they were equations rather than inequalities, and then insert my inequalities second. So, let's look at the dotted line. I note right away that I have a y-intercept of -1. So my b value is -1. Now, I need to find my slope next. So I'm just going to pick another really easy point to move to, right there. So I know that I'm going up 1 unit, 2 units, and over to the right 1, 2, 3 units. So that would be written as up to the right 3, 2/3. Now with that data, or that information I should say, you would write your equation, if it were an equation, as y equals 2/3 x minus It's an inequality. It's a dotted line. So we're going to rewrite this for our system. The shading is occurring above the dotted line, so it's going to face the y. And it's a dotted line, so it's just going to be greater than 2/3 x minus 1. We do the same thing with my other line. This is a vertical line. What is the slope of a vertical line? Undefined. Is it x equals or y equals? X. So undefined slope vertical line is x. So if it were an equation, again, it would be x equals 3. It's not. It's going to be an inequality. So in this case, x. And then for x's, I ask myself if it's going to the left or to the right. Is the shading going to the left or to the right? To the left, so it's going to face away. And it is solid, so less than or equal to 3. So here is my system. Do you have any questions? Hopefully this isn't too bad. Okay, so if you are watching this at home, take some time to pause this video and try them yourself. Write a system of linear inequalities represented by the graph. Those of you in class, here are the solutions to those systems. You should have y is less than negative x plus 2 and x less than 3. Now you don't have to necessarily write the and, you can write them one on top of the other as your system. And what some people do with systems is they will do this. They will write y is less than negative x plus 2, x is less than 3, and then have this little bracket thing to indicate your system. Okay. So do whatever, as long as you make clear to me what the two inequalities are for your system. 2 or more, I should say. All right, I'm going to go ahead and end this recording today. Tomorrow we will be doing the word problem for bell work, and if you're gone tomorrow, we will be doing step up to writing. You will need to come in and make up that task, or email me for the worksheet for the step up to writing. Here is your updated table of contents. The new assignment is item number 15, 5.7, page 278, 3 through 29, odd. 29 is the word problem, or mimics the word problem that we will be tackling tomorrow.